If you want to become a software engineer and you don't have a roadmap, you're pretty much already screwed. I can speak from experience because this is the exact issue I had when I started learning how to code nearly 10 years ago. One day you load up the computer, you get a bit of motivation, you dive into a few tutorials, you feel like you're making a lot of progress, and then the next day you have no idea what you're supposed to be learning. This is common, don't feel bad if it's happening to you, and that's why I'm making this video, because I want to share with you 4 really good roadmaps that you can follow that not only are going to help you make a lot of progress, but help you actually land a job. Now, one of the important things when it comes to becoming a software engineer is to make sure you're going down a certain path. It's very difficult to be employed as a software engineer if you just have very general skills. If you just know a little bit of Python, a little bit of JavaScript, you picked up a bit of Git, no one really needs someone that does just that. Pretty much all software engineers have at least a little bit of skill in that area. You need to pick what kind of area of software development you want to get into, and that's what this video will help you with. Now, before we get into the 4 roadmaps, I do want to break down some core skills that all software engineers have to have, no matter what area you want to get into, so let's start with those. So to be a software engineer, you obviously need to know how to program. You need to know how to write basic code and probably even more advanced code. And you need to understand all of those core concepts that I'm sure you've heard a lot of times. Functions, if statements, print statements, conditions, variables, all that stuff, you need to know it no matter what programming language or what you're going to end up doing as an engineer. Next, you need to understand data structures and algorithms. Now, as much as a lot of people like to complain that these aren't commonly used in your job, they are a really core, important part of kind of a computer science curriculum or becoming a software engineer. And even though you may not be implementing a binary search or reversing a linked list on your job, the skills that you learn when you learn these topics carry over into a lot of other fields, and being able to understand algorithm efficiency, space and time complexity, how to write a better solution than another solution, and comparing 2 pieces of code together is really, really important, and everyone needs to know it. Now, the next core skill you need to learn is how to use your computer, and specifically how to navigate the command line using bash commands. Now, these can be other commands as well. You can be learning specifically for Mac or Windows, but you should be comfortable navigating the computer using the command line, understanding commands like cd, pwd, MV, RM, CP. If those commands mean nothing to you, then you've got a little bit of work to do. It won't take you very long, but you should just understand the basics of those. Now, after that, you're going to want to know Git. No matter what you do, you're going to be using some kind of version control system. Most likely it's going to be Git. So you want to understand the Git commands, what repositories are, how you push things to a remote repository, work with multiple people. These are things that, again, don't take a massive amount of time to learn, but are really fundamental and you can't skip over. Now, lastly, you also want to learn about coding best practices. What is the best way to write code? What is the most efficient? What is the cleanest? What is the most maintainable and readable? And how do you write code that other people are going to be working on, not just code that's strictly for yourself? Once you've got those core skills down, then it is really time to dial in on a roadmap in a specific area of software development, and that's what we'll get into now. Now, I have 4 roadmaps for you in this video. The first is data science and machine learning. The second is front-end development. The next is back-end development, and the last is mobile development. Now, make no mistake, there are hundreds of different roadmaps you can follow along with, and I can't possibly put them all in this video, but these 4 are very popular and the ones I see a lot of people having success with, hence why we'll get into them. So let's begin with data science and machine learning. Now, you could also throw the term AI in here if you want, working with LLMs, etc. And yes, there is a difference between AI, machine learning, and data science, but at least when you're getting started, most people are going to follow pretty much the exact same roadmap to build that core competence before they decide to specialize, specifically in machine learning or data science or in things like AI and LLMs. So this roadmap will definitely do you well, especially if you're just getting started. And by the way, if you are interested in learning more about AI, data science, machine learning, etc., then today's sponsor, datacamp, is a great place to start. Whether you're a complete beginner or just looking to boost your skills to break into software development, datacamp is an incredible resource. You can start by taking an assessment to identify where you have gaps in your coding knowledge, especially in Python, SQL, or R. Based on your results, datacamp recommends relevant courses from over 500 options in data science and AI. You'll develop your skills with a super interactive learning experience through short videos and hands-on exercises. What I really like about datacamp is that you learn by doing. Exercises will require you to write code in the programming languages that you're learning, and you'll build confidence by working on real-life projects. And once you're ready, datacamp even offers industry-recognized certification programs, whether you want to become a data analyst, data scientist, or data engineer. Datacamp certifications are a powerful asset to stand out in front of recruiters and help you land that first data job faster. Check out the links in the description to get started and level up your coding skills with datacamp and eventually become a certified data professional. So let's get into the roadmap. Now, the first thing you're going to want to know is Python. Now, you can learn a language like R. You can even do this with Java, for example, or C++, but for most people, their best bet's going to be Python, and that's going to be the lowest friction to get started. Now, after that, I do recommend having a solid foundation in mathematics and probability and statistics. You don't need to have this in order to go through this field, but it's definitely very helpful because a lot of the things you'll end up encountering have things like scientific notation. They have all kinds of maybe calculus mathematics they're showing to you, and things that I don't even understand because I didn't finish all of my math classes in university. And the point is, if you really want to have a deep understanding in this field, yes, you do need to know a bit of math, and that's probably one of the only areas in machine learning where you do actually need to be decent at math. So things like linear algebra, calculus 1, calculus 2, even things like discrete mathematics can help you tremendously. If you don't have them, you can still get into this, but those are topics you're probably going to want to learn about, and you will end up being exposed to as you go through your research and learning process. Now, once you've learned that, you're going to get into data pre-processing. Before you can start handing data off to machine learning models and performing all of this analysis, you need to pre-process it. That could be using modules like pandas, for example, or NumPy to change the data shape, to collect the elements that you need, to clean the data. There's all kinds of different things that go into that. Next, you're going to learn about machine learning algorithms, specifically these core ones. Now, I'm just going to read these from my notes so I don't get them wrong. We have linear regression, logistic regression, decision trees, random forests, support vector machines, and k-nearest neighbors. But these are really the important fundamental algorithms that everything builds upon, and it's important to understand how they work at a deeper level before you go much further. Next, we have model evaluation. Once you've trained models, you've learned about these core algorithms, and you've pre-processed the data, you need to know how to evaluate them for their performance. So you can learn about things like cross-validation, ROC curves, confusion matrices, and there's other techniques as well that you can use to fine-tune your model's performance. Now, after that, you can start getting into more complex techniques like neural networks. You'll start by learning about the basic architecture of neural networks and then start looking at things like convolutional neural networks, recurrent neural networks, and more complex architecture for specific tasks. Now, while you're learning about neural networks, it's very likely that you're going to be touching frameworks like Keras, PyTorch, and TensorFlow, so keep those in mind as some important tools that you'll want to watch out for. You don't need to know all of them, but certain courses will favor, for example, PyTorch or maybe TensorFlow. That's the one supported by Google. Next, after that, we have natural language processing. This is a big area specifically now with things like LLMs. So this is where I would learn about things like text pre-processing, word embeddings, and models like BERT or GPT, which probably sound familiar to you. Now, after that, we have computer vision. Now, computer vision is my favorite area in machine learning and AI because I just find it so cool. And in this space, you can use things like OpenCV, and you can learn more about things like convolutional neural networks and how you use audio, video, photos, and how you actually recognize things in the real world using AI, which again, I find really interesting. After that, you can start looking into reinforcement learning. You can learn about things like Q-learning, agents, environments, how you have models kind of train themselves. You can start looking into things like evolutionary algorithms. And obviously, at some point, you are going to be looking at LLMs. Now, realistically, you won't build your own LLMs, but you'll probably be learning about how they work, and that's definitely useful. Okay, so I know that was a lot of stuff. So what I'm going to do now is give you a quick summary of things like the languages you can learn, the libraries or frameworks, and the different tools. Now, again, if you see me referencing my other monitor, it's just because I don't want to get these things wrong. I have some notes. Okay, so in terms of languages, we have Python and R. Those are the primary languages for this category. However, sometimes you can do this in Java and C++. It's just not as common. Next, we have things like scikit-learn. This is for kind of implementing those more basic machine learning algorithms. We have things like TensorFlow, PyTorch, Keras, and then OpenCV, NLTK, Natural Language Toolkit. And then lastly on my list, I have Spacey in terms of kind of the frameworks and libraries. Next, in terms of some tools you'll end up probably learning along the way. First is Jupyter Notebooks. Now, these are typically Python notebooks that allow you to run interactive code. Very useful tool to learn, very simple to learn, and you can use them in VS Code or in cloud environments like Google Colab. Next, we have Google Colab. This is a kind of online environment where you can execute machine learning code against GPUs, and you can do this completely for free if you don't have a great hardware setup in your own, desk, computer, whatever. Next, we have some cloud providers like Amazon Web Service, Azure AI, or Cloud AI from Google. Now, you can pick just one of these. You don't need to learn all three of them, but eventually you'll get to the point where you want to actually deploy your models, and then you'll need to learn a bit about cloud services. So that wraps it up for this category. I know that was long, but I want to give you a lot of information. Now let's get on to front-end development. So we're diving into front-end development. Now, before you can really become a front-end developer, you do need to learn three core things: HTML, CSS, and JavaScript. Now, these are three independent languages. Some people will argue HTML is not a programming language. That's fine, markup language, whatever you want to call it. The point is, you need to know these three things before you can really start doing any kind of substantial web development. So learn the basics of HTML, learn about the different elements, learn about things like semantic HTML and the correct way to use different tags. Next, learn about CSS. You don't need to be a master, but you need to know about things like layouts, basic design properties, and pretty much 90% of the CSS you'll use on a daily basis, you can learn in about 1 hour. Again, you might not be an expert in it, but you don't need to know a massive amount to get started here. Next, you do need to know JavaScript. Now, this is where you really need to focus a lot of time because you're going to be writing tons of JavaScript or TypeScript code when you're doing front-end development. That's really just how it is nowadays. Yes, there is other languages you can use on the front end, but typically it's going to be in JavaScript. Now, once you've learned those three things, it's time to get into a framework. Now, in order to be a great front-end developer, you need to be good in one of the three major frameworks. Now, that's React, Angular, or Vue. Now, you can pick which one you want to get into here. Personally, I like React. That's just the one that I use the most, but you have all kinds of people online arguing about which one is the best. If you want the most number of jobs, that's probably going to be in React, but if you want to be more specialized, you can go and learn things like Angular and Vue. Actually, I recommend that you learn a little bit about all three before you make a decision. Anyways, point is, learn a bit of these three frameworks, pick one that you like and that you want to stick with, and then follow the roadmap from this point forward. So once you've picked a framework, the next thing you're going to be learning is obviously about that framework, the ins and the outs, all the details, and then you're going to get into state management. Now, this becomes more and more important the larger the application becomes. There's all kinds of frameworks or libraries that can help you with state management, but regardless, you want to learn about the native state management ways. So if you're in React, things like the context API, and then you potentially want to look outside of that at things like Redux, for example. They also have state management libraries, obviously, for all of the other frameworks. The point is, you need to get good at state management and kind of understand how that impacts the performance of your application and how you design apps with state in mind. So now that you've learned at least the core components of one of the frameworks, you've learned about state management, it's time to really dive into more complex web development concepts. So firstly, things like responsive design. Now, theoretically, you could learn this before the frameworks, but I find it's nice to have a bit of experience in the framework first, and then you can really see how this impacts what you're doing and what you're building. So responsive design is how does your website scale from, say, a really huge screen to a really small screen, like a smartphone? Does it work on multiple browsers? That's kind of responsive design. How does it change as you change the layout, size, and dynamics of the web page? Next, you want to really focus on APIs and how you interact with APIs. Now, APIs are going to use all the time as a front-end developer. This is the way that you're going to retrieve data or update data, and it does involve learning a little bit about how the backend works so you can really truly appreciate what an API is and what your role is as a front-end developer in using it and interacting with it. Now, after that, you want to learn about things like accessibility. So does your website work for people that are colorblind, for example? Does it work for people that are using screen readers? Does the text scale? Is it larger for people that have that setting set in Google Chrome? There's all kinds of weird accessibility features that a lot of people don't think about, and definitely if you want to be a front-end developer, you want to understand those concepts and try to make your websites as accessible as possible. Next, you're going to be looking at performance optimization optimization. So how do I make my web page as fast as possible? Is the way that I'm writing code the most efficient and scalable? Is there ways that I can handle the state that will result in less state updates, for example? This is where you get into more complex topics and you're focused more on kind of specific blocks of code and small techniques that you can use to really optimize the performance of your site. So once you've learned all that, now we move into what I'm calling the extras. Now these are other topics that you should learn, but they kind of don't fall into a category like the ones did before. So we have TypeScript. Now TypeScript is a programming language. It's actually a superset of JavaScript, and this adds type annotations and hints and static type checking to JavaScript. You don't need to know what all of that means, but the point is TypeScript is used everywhere, and if you are a front-end developer, you're going to be expected to understand TypeScript. Fortunately, it doesn't take that long to learn it, and 95% of the TypeScript you write on a day-to-day basis can be learned in about an hour. That's how I learned TypeScript. I needed to use it for a project. I watched an hour-long tutorial. I was pretty much good to go and just had to look up a few things when there was some more complex syntax. After that, we have testing. Now, testing is an important role for software developers, so you should learn about the difference between unit tests, integration tests, and end-to-end testing or system tests, whatever you want to call them, and different testing frameworks you can use based on the front-end code that you're writing. Next, we have animations. Now, I wouldn't say you need to be an expert here, but you should understand basic CSS media queries and how you do some kind of more advanced things with your web page to almost show off or at least just make some more interactive and kind of engaging sites. I find animations interesting. I suck at them, but something you should learn. Next, we have Next.js. Now, Next.js is server-side rendering. This is kind of a whole different category. I could do a whole Next.js roadmap for you, but you should dabble in this, look at it a little bit. It's not like you need to start writing all of your code in Next.js, but it is a topic you're going to want to be familiar with because it's gaining a lot of popularity, and a lot of companies now are using Next.js in their code bases. Okay, so that's that. Now we get into tools and workflows. Now you're going to want to learn about development tools, so things like Webpack, Babel, NPM to manage things like your dependencies, and then build processes. So how do you actually build an application? How do you go from writing it in JavaScript to rendering it on the web? If you're going to be a front-end developer, those are important topics to understand. Now you're also going to want to learn a little bit about DevOps, how you actually deploy applications out. You don't need to be an expert here, but learning about things like CI and CD pipelines, how you set up automated testing for your applications, how you do things like continuous integration, and using applications like Netlify, Vercel, that's a really popular one now, or GitHub Actions. Lastly, you want to learn about some browser dev tools. Now, at some point, you're going to have to learn these anyways, but these are things like debugging, profiling, and testing the performance of your application in the browser, which obviously is where it's natively rendered. So now we're moving on to backend development. Now, backend development is one of those fields where there's many different valid paths and ways to do backend development. Now here, just to narrow the scope a bit, I'm talking specifically about backend web development, but you could be a backend developer working on, for example, internal tools. It doesn't just need to be web development, but that is one of the more popular categories. Okay, so the first thing you need to do if you want to become a backend developer is identify what language you want to primarily write code in. Now, there's a lot of different options here. I'm going to give them to you, and you might just want to pick the one that you're most comfortable with if you've already learned one. If not, I'll give you some recommendations, but let's go through the options. So we have Node.js or JavaScript, right? So if you're writing code in JavaScript for backend, you're typically going to be working with Node and something like the Express framework. Then we have Python. This is personally what I use. And then you're going to be working with something like Django or Flask or Fast API. And then we have Ruby. Obviously, you'll be working with something like Rails. Then we have Java. This is a very popular option because a lot of more legacy code bases are written in Java and they need people to maintain that. Then we have .NET, so we're talking about things like C#, ASP.NET. We have Go, obviously, a more modern language, personally one of my favorites other than Python. And then, of course, we have all kinds of other languages, Rust, C++, etc. But the 6 that I listed are some of the more popular ones when it comes to backend web development. Now, truthfully, you can go into any of these languages. If for some reason you like a language better than another, then go ahead and pick that. But I would recommend looking at different job postings for companies you might want to work for and seeing which ones are listing which languages and then focusing in on that. One of the best ways to develop a roadmap is to go and look at what companies actually want, see all of those different resources, tools, languages, libraries that they're listing, and then make a note of those, kind of cross-reference them against other applications and see which ones are popping up the most. But obviously, I'm going to help give you a shortcut in this video. Okay, so ideally you picked one of those languages or kind of ecosystems of backend development, and now what we need to do is learn some concepts that are going to apply to pretty much all backend developers. Now the first is a database management system. Now this could be a SQL database, something like Postgres or MySQL, or it could be a NoSQL database like MongoDB, even something like Firebase that could work as well. But ideally you're going to learn both, so a SQL database and a NoSQL database, and understand how to do things like structure queries, how databases actually work, the difference between SQL and NoSQL. These are just core important concepts that all backend developers should know. Next, you need to learn about APIs, specifically REST APIs and how APIs work and what they are. What are the different request methods? How do you make an API? And then look into things, for example, like GraphQL, kind of a way of making APIs and querying different data sources. After that, you're going to want to start looking at authentication. Having APIs are great, building backend services are great, but you need to authenticate them. So learning about things like JWT tokens, other token-based authentication mechanisms, usernames and password, basic cryptography, how you store passwords securely, and what authentication looks like and how you perform it, which can be drastically different depending on the type of framework you're working in. Now, after authentication, I'd recommend looking into testing. So how do you do, again, unit testing, integration testing, end-to-end testing of your backend systems? And then you're going to probably be looking at caching. So looking at tools like Redis, for example, to increase the performance of your applications. After that, you might want to even look at things like message queues and different design patterns you can use on your backend. There really is a lot of stuff that you can cover here. I'm kind of giving you some more general, broad terms because it is difficult and it depends on the specific kind of language or ecosystem you get into. But hopefully this gives you at least a little bit of guidance. Now, after that, there is a bunch of other skills that I would recommend learning. You don't necessarily need to know all of them, but I'm going to give you a list in case you'd like to see them. So first we have DevOps. Now, as a backend developer, I'd recommend learning about things like Docker, Kubernetes, and continuous integration and deployment. So same thing kind of on the front end, you want to learn how to deploy your applications, how to use containers like Docker, how you can set up Kubernetes clusters and kind of how that works in terms of spinning up different pods and services. And then things like CI and CD. So this is GitHub Actions, automated testing, automated deployment. Again, you don't need to know all of this, especially as a complete beginner, but it's good to at least know a little bit about it so that if it does come up or those terms are thrown around, you're not completely lost. Next, we get into cloud platforms. So things like AWS, Google Cloud, Azure, other cloud providers, you're going to want to know at least one of them in terms of how you deploy applications and interact with them. And then we start getting into various architectures when it comes to backend development. Backend development requires a lot more kind of, I'd say maybe strategic thinking, critical thinking, architecture decisions, because you're working on kind of the performance side of code. If the front end is a little bit laggy, that's okay. People can deal with that. The data is still integral, it still works, everything's secure. On the back end, things are a lot more critical, so everything you do has kind of a higher impact on an organization as opposed to, a fancy front end where the animation doesn't work, right? What's more of an issue if the database goes down or if the, front end website is, a little bit broken, right? The database obviously is a bigger issue. So this is where I would start looking into things like serverless architecture, so serverless cloud functions, for example, and then things like microservice architecture. This is creating a bunch of small services rather than kind of a monolithic application. And then we of course get into things like monitoring and logging. Okay, I have this great application, it's deployed. How do I see if it's actually working? How do I check the latency and the speeds? How do I monitor that and log that? I maybe share that information with other team members. There is a lot of stuff when it comes to backend development, but that is kind of a gist of some core competencies and skills you'll want to learn. So now we move on to mobile app development. Now this is a bit more of a niche field. Sure, it's still very popular. Many people know about it, but a lot of developers don't ever learn any mobile app development. So I find a lot of the roles for that aren't nearly as competitive as something like a front-end developer or a back-end developer because you just have less qualified candidates. Now you also have less roles, but I think this is definitely something worth considering. And the nice thing about being a mobile app developer is once you learn this, you can build your own applications. You can very easily start up your own company by having these skills, which is actually something that I did recently. So I was working as a mobile app developer for about 2 years for a tech startup. I did this with a team of about 4 other software engineers where I was the lead engineer there. So I have a bit of experience in this field. Our app didn't end up panning out, but it was definitely a great learning experience. And I'll kind of share with you the roadmap and some things I learned along the way. So you have a lot of options when it comes to mobile app development, but you want to probably pick whether you want to make apps for iOS or Android. Now we also have cross-platform app development using frameworks like React Native, for example. But in my experience, it is significantly easier to build applications when you build them natively for the platform. So when I worked as a mobile app developer, I worked in React Native. This meant I could just take my existing React skills and JavaScript skills and then build apps that worked on both Android and iOS. But what I found is that it was very difficult to get things to work flawlessly on both operating systems. And even though we eventually did that, I always was thinking in the back of my head, it would just be easier to have two separate code bases here that shared, for example, a backend, rather than trying to build one thing that worked everywhere. Because once an app starts getting complex, there's just a lot of things that are different on iOS and Android, and it's a little bit of a nightmare, and your app just doesn't run as smooth or kind of fast or quick or nicely as it does when you build it natively. Anyways, that kind of is the first option. If you know React, if you know JavaScript, and you want to start building mobile apps really quickly, using React Native is a great option, but when it starts getting really large, it's a bit of a nightmare, so I'm just giving you a warning right now. Now, the next options here are to build in iOS or Android. So if you're building with iOS, you pretty much need to use Xcode. Even if you're using something like React Native, you're going to be using Xcode for parts of that, and you're probably going to want to learn Swift. Swift is the newer, more modern language for building mobile apps. I mean, it's pretty old now, but it was new at some point. Previously, it was Objective-C. At some point, you might come across some Objective-C code, but generally, you can learn the Swift programming language. You can learn Xcode, which is its own kind of language, its own environment to mess with, and then you can start building iOS apps, iPad apps, pretty much anything in that Apple ecosystem. Next, we have Android. Now, Android, I would say, is a lot easier to build on, especially when you're getting started. And for this, you can learn Kotlin or you can learn Java. Now, with this, you're going to be working within Android Studio, and you can, again, build out mobile applications in either of those two languages. And it is significantly easier, just easier to test. Everything has a lot less friction when you do Android. So anyways, kind of pick, do you want to do iOS? Do you want to do Android? Do you want to do both? And then select out of those languages and kind of the editors or frameworks that I mentioned. Now, before we go any further, I will mention there are some other cross-platform options. So for example, we had Flutter that uses the Dart programming language. Next, we have things like Xamarin Studio. You may have seen this before, allows you to build mobile apps in C#. Again, this is okay, but I would personally just recommend if you want to be a mobile app developer, build it in a native language. It's just going to be a lot easier than trying to use it in C# or React Native or JavaScript or whatever you want to use. Okay, now once you've picked what you want to learn, you're going to need to learn the ecosystem within that platform. Mobile app development is a lot more complex, in my opinion, than developing on the web, because there's just a lot of new things to learn and you're dealing with kind of native components. So for example, on iOS, you're dealing with, the weird like interactive thing that's shrinking now. What is it called? The floating touch bar at the top where the notch used to be, like just things like that. An update comes out, all of a sudden the iOS is different and the gestures are different. So you're just dealing with something you don't really have that much control over, whereas a web browser is quite simple. It's just this kind of 2D static environment that you're writing code in. In mobile app development, you're dealing with all of the hardware components and software components of the mobile phone that you're on. So for example, if you're writing code for Apple, right, on an iOS device, you also have to make sure your code is compliant. So you have to go through a review process. You're going to need to learn about, okay, what does it take to actually deploy an iOS application? What does the review process look like? How do I get logs back from this application? What are different packages I'm even able to install that work with iOS? So that's what I mean by the ecosystem. With Android Studio, it's a lot easier, but you're deploying to, for example, the Google Play Store. So you want to learn about how that works. What is the deployment process? How do I actually get my app here? What devices is this compatible on? What SDK versions does this work for? There's a lot of kind of mobile specific topics that you're going to end up learning in this journey. Now, other than that, you're obviously going to need to focus on things like responsive design, user interface design, building things specifically for mobile. For example, certain touch areas are kind of a no-go based on where users' thumbs can be placed. So there's a lot of kind of learning curves there. Now, beyond that, this is just building the front end, right? Like if I build a front end in Xcode using Swift, I still have some backend I need to connect it to, some kind of database. So you are also probably going to need to learn a bit about backend development if you want it to be a full stack mobile app developer. If you're just building the front end and the app, that's one thing, but the back end is also another component. So you need to think about, okay, where is my data stored? How do I access the data? And that's where you can get even back into the backend developer roadmap. So long story short, mobile app development, in my opinion, is more complicated. I think it's definitely worth getting into, and it's very rewarding when you learn it and you can build out some really cool stuff, but you are dealing with a lot more complexity and kind of moving parts and factors compared to building web applications. Anyways, that's kind of a simple roadmap. I know it was more just information than it was, learn this. It's just because the platforms are so different, and it's very difficult to give a step-by-step roadmap because it really depends on what you want to do. So with that said, guys, that's going to wrap up this video. It ended up being a lot longer than I was expecting, but again, I always try to give you as much information as I can, so I hope you found this valuable, and if you did, just leave a comment right now and let me know what roadmap you plan on pursuing, or if it's completely different, or if you have any feedback for me or kind of a roadmap that you might suggest. Anyways, hope you guys enjoyed, and I will see you in the next one.